Hello, everyone. My name is Rafi Sultan. I am a PhD candidate in Western University. Today, I'm going to present our paper that has been published in this year, CVPR 2026, WalkGPT, Grounded Visual Language Conversation with Depth-Aware Segmentation for Pedestrian Navigation. To talk about the motivation of this paper, this was built around the need of the themselves. So we care about the pedestrian navigation, which requires more than the scene description itself. Users need to know what is walkable, what is harmful, and how far the objects are in front of them. The potential solution to this are like existing large vision language model, but they can only describe pedestrian view scenes, often lack reliable grounding, depth, or spatial understanding. So the need for grounding guidance is imminent, and the guidance should connect the language to visual language via the segmentation mask and the distance estimates. Hence, we introduce WalkGPT, which is a large visual language model, which uh, you takes a pedestrian view image and a question as input, generates a natural language accessibility response that includes the accessible and harmful features that are grounded, and it gives us the segmentation mask in of all the features available. And also alongside, it gives the object level distance from the user himself. So this is our overall method for the work GPT. So as we said before, it takes a question input, it takes a visual input. The visual input as the image itself goes into the pixel encoder. This pixel encoder is a shared encoder that does the both segment for the segmentation and also uses the embeddings from this embeddings encoder that goes into the LLM itself. First, the image goes into the pixel encoder, it gives the encoder embeddings, and it goes into the MSQP, which is one of the novelties of this work. This MSQP, the multi-scale query projector, is just a simple projector that looks at the scene in multiple zoom levels so that the image tokens that goes into the large language model has much more understanding of the fine-grained things that are happening. So when the large language model generates these output tokens, we have some structured tokens available. So among them, each of the seg tokens is generated after each of the related features that can be accessible or harmful. These seg tokens, we extract them. We use the hidden states of these seg tokens that goes into another projector, which we call the CTP, the calibrated text projector. It's a simple, it's another projector kind of thing where it kind of expands the understanding. And while we do the projection, it retains more information compared to the existing projector out there. And this CTP projects them to the pixel space, goes into the pixel decoder, and works as a prompt for the segmentation. So every time we generate a segment, each of the segmentation tokens creates a different segmentation mask, and these are alongside the output of the generated answer and the segmentation mask. Also, when we do train the CTP, we have a region alignment loss, so it kind of makes sure that the when the projection happens, the sec tokens goes into the pixel space. It actually points to the region of the related features. Like if we say it's a sec of sec tokens of the crosswalk, it should point to the sec token, the region of the crosswalk itself. We also generate this PEV dataset, which we need the structure token to do our training. And we use an LLM model to create this 41K sample benchmark that we used to train our model, which has all the generated structures, answers with the grounding tokens, distance descriptions, etc. Finally, we have some results where we show that our model, WalkGPT of both 7 billion and 13 billion, proves better in comparing to some existing large visual language models. And we also see that the zero-shot version of each of this model fails miserably in this hard task of pedestrian navigation. We have some quantitative results in different scenarios from our dataset. We show that how hard it is um, uh, in the real world to do the pedestrian navigation and how what the WalkGPT gets input and output as an overall. So basically, that's our That's our paper, WalkGPT. We introduce grounded navigation with mask and distance guidance, and we have the benchmark that's released publicly. And we show that some strong empirical results for our model. Thank you for listening.